Hello. Today, can you all hear me?
Yeah.
Okay. Um, Today we're gonna talk about a bit of the autonomous, and we're gonna write a sample program.
Okay.
So, did you happen to? Do I need to catch you up on last week's lesson, or like 2 weeks ago?
What were the other lessons on?
Last time we talked about like how the autonomous program, how to like write a autonomous program.
Mhm.
I can cover that like while I'm doing this week's lesson. So,
Okay, that would be great. Thank you.
all right.
Thank you so much.
So, to give a quick recap, I said to write an autonomous program, they differ in two ways from the teleop. First is this tag. You always need this add autonomous tag because that's what tells the phone that this is an autonomous program.
Okay.
And you just give it a name, and that's the name that you're going to see on the phone. So when you like open up the Android phone to choose like what program to run while you're at competition, then you're just going to look for the name that you provide right there. And usually you try to get the name to be a bit descriptive so you can easily tell what program you're trying to run. And another thing is this group equals autonomous and also linear OP mode. And that was the big distinction I talked about the last time we had a session where I said when you do an OP mode, what that does, you can see right here, and you can also see this has a teleop tag. But what OP mode does is it keeps looping through the same code. So you're just going to keep running this until the game ends. But with an autonomous program, um, you don't have to be running the program like over and over again because you have a set list of objectives you want the robot to fulfill. So once the robot finishes all those, the robot can stop. Does that make sense?
Yeah, that makes sense. Thank you.
Okay. So we're gonna write a quick program just to like make the robot go forward. So what I'm gonna do is right here, you want to put all your code inside team code, and just I'm gonna right click new, and then new Java class, and then make this sample autonomous. So I'm just gonna get some. So if you just type it, it should like automatically import it for you, which is where importing is when you get like a software package that someone else made, and you use that for your own code. And the first thing I'm gonna do is I'm gonna set up some variables so I can actually control the stuff. Hold on. I haven't written this in a while, so I'm gonna need some refreshers. We're gonna work off of our original drivetrain. I'm pretty sure I can still access the stuff. And then since whenever you extend something, sometimes you need to write some methods that they force you to implement. And what that means is sometimes there's like code that you have to write for all types of linear OP modes. And it kind of makes sense because you don't want someone to write a program for an autonomous and not have anything to run because the phone's going to be expecting something, but then there's not going to be anything there. I'm going to call this sample and then autonomous. That's what I forgot. Okay. And in here, what I'm gonna do is robot. I'm gonna initialize my robot. Um, hmm. Let me see what I did wrong here. Oh yeah. And then with this robot, we're gonna want it to. So you have all these methods I wrote. So if you wanted to drive straight along, to just drive straight, I'm just gonna say drive straight at a speed of 0.5, so 50% speed. Drive straight for like 30 inches, and then drive straight along 0 degrees. And what that means is, can you see this drawing I just made?
Yes.
Okay. So with this robot, there's always going to be like a forwards, so you're going to have some wheels. And then the robot can face like forwards, it can face backwards. Um but what you want it to do is you don't want the robot to start like tilting like to the side, because there might be like some like dust on the field or something like that that makes that makes the wheels not move very well. So when the wheels don't move very well, the robot might like drift off. So instead of going straight forwards and actually reaching the place you want to hit, you might start driving at a small angle. So when I tell this relative angle, that means I want the robot to go straight along 0 degrees. And 0 degrees is whichever way the robot's pointing when you like turn the robot on. So I turn the robot on, I get a 0 degrees. So if this was the way the robot was facing when I turned it on, this is 0 degrees. And the robot will keep trying to correct itself. So when it tries to go that way, it turns back that way to hit 0 degrees. And now I guess the question is, like, what's really happening when I'm hitting this? So robot dot, I'm gonna go into the robot class to show you, and I'm gonna make this public just so I can access them myself. But I'm gonna change that back to private. And what public means is I can like change stuff to these variables outside of the class. And the reason why you might want something private would be, let's say you were writing like a video game and you had like a private point in like your score. You don't want like people to be able to change their score outside of the game. So if you made it public, then someone could easily get a copy of your game code, and they could just write like score equals 1000, like whatever that is. So private is just to like keep your code a bit safe, so you don't accidentally change stuff outside. Because when you change stuff outside of your code, and when something goes wrong, it probably went wrong. One of the things that might have broke your code is that you changed something like outside, like you might have made right front motor, I don't know, go at 100% speed all the time by accident, and you might have forgot about that change. But then your code inside here thought that that wheel should have been going at a different speed. So it's a bit of those like conflicts when you have like two separate like parties interacting with the same data, and they're trying to do their own things with it. But I made it public, so now I can actually access it. So I'm going to do robot. So how do you make a wheel go forwards? And you would do robot dot right back motor dot set speed, set power. So when you set power to 0.5, I'm going to set all of them to 0.5. What do you think that does? Any ideas on what set it?
Um, for like the speed because it's like power. I don't know.
Yeah, exactly. So the way that you get something to go at 50% speed for 20 seconds, we're gonna start at like a basic level, then we're gonna go to something a bit better than that, and then we're just gonna get to this code. So the way that you would make something go at 50% speed for, let's say, 2,000 milliseconds, that would be 2 seconds, would be you set them all to go at 0.5, and then sleep 2,000, pauses your code for like 2,000 milliseconds. So that means whatever's after here, it doesn't run until 2,000 milliseconds. So if you set like robot dot, and then you set those to 0, the robot's going to keep going at 50% speed for 2 seconds. So that's like a very basic way to make a robot go forwards. You just give it a speed, and you tell it to go forward at that speed for 2,000 milliseconds. Does that make sense?
Yeah.
Yeah, but the problem with using time to control your robot is that this time, I think the explanation was that it changes based on the robot's battery level. So if you're not running at full power, like when you say 0.5 there, that's not actually 0.5 or something. I don't know the full explanation, but it's just that the sleep, it's not very consistent. So you might have thought that you wrote 2,000 milliseconds there, but then when you run it at like, I don't know, when you're at 50% battery versus 100% battery, it might not actually run for 2,000 milliseconds for the full 2,000 milliseconds. Does that make sense?
Yeah.
Okay. So we're gonna do. Oh yes. Mark gave the good explanation. The computer could change the speed of the clock based on like the battery power, I think. So that's why the 2,000 milliseconds is not always 2,000. So that's why it's not so accurate. I think that's the explanation. So we're gonna go to level 2 now. That's something that's a bit better than this, and that's something that pretty much this code does. The code I just commented out. So the first thing you want to do is you want to set the mode to so what you want to do here is, let me clear my drawings. So what you want to do is you want to use something called an encoder, and that's a cable you connect to your motor. And what these encoders do is, let's say you had this little motor here, and it was like, turning around, turning around, turning around, turning around. When you go a full 360 degrees, this encoder is gonna count like how many times it's turned, and it counts this through a system called counting ticks, where once you rotate the full 360 degrees, it would have counted like, I think some motors you get like 5,000 ticks per turn per every 360 degrees. That means your tick number would have gone up by 5,000. It's kind of like if you imagine that your wheel had like little spokes inside. What these encoders do is they count how many of those spokes you've touched. So once you touch all 5,000 spokes, that means you've reached 360 degrees.
Okay, that makes sense.
All right, great. So with these encoders, since these encoders are able to like count how many angles you've turned, do you see how you might be able to use that to calculate like distances?
Yeah.
Yeah, you use the wheel circumference, and then you like plug that in to get whatever distance you want. And what I'm doing right here is a very important step. You always want to reset your encoder to get rid of any like previous values.
Okay.
That's just an important step to do. It's like you want to like always like when you're in science class and you get a scale, the teacher always tells you to zero it before you actually use it. That's
Yeah.
kind of what you're doing right here.
Okay.
And then what you do is we set another mode. Now that we reset the encoders, I didn't have to change this. Yeah, Mark, I actually have a so you can't reset them all in one line of code, but I wrote a method to reset them all at once. You just have to call it once. It's right here. Um, but yeah. So this run using encoder, that's a bit misleading. That's not the thing you actually want to use. I think run using encoder, that's more for like when you want to do what I did the first time when I just set a speed and then paused it. It's like sleep 2000. That's more like